All right, this problem is an application of solving a quadratic equation. And application means we're applying our knowledge to a real-world situation. One of the first problems I ever did in the real world, I had a friend of mine was making a railing to go up to a house, and he wanted to know how high off and how far away it was based on the length that he had. So it was a problem very similar to this. And we have to know the Pythagorean Theorem when we're dealing with a right triangle. Okay, if it has a right angle, Pythagorean Theorem is the way to go. And what this says is that the side that is C, if I square it, it's equal to the square of the A side and the square of the B side. And the C side is called the hypotenuse. So you have to know that this one is C. We can label this one A or B. We can label this one A or B. It doesn't matter. But this part right here has to be C. So I will call the one on the left A. That'll be the short side for this diagram. And then I'll call this one B. This is the long side for this diagram. And all we have to do is we have to plug in our A, B, and C into this Pythagorean theorem. So A, it's a binomial, x minus 7. B is x, and C is x plus 2. So let's go ahead and plug those three in, turn it into an equation, and then we'll have to use our math to solve. So A squared plus B squared equals C squared. Now our A, we labeled that as x minus 7. Our B is just x, and our C is x plus 2. All right, we have our equation. Let's go ahead and let's square this binomial. This squared, well, x squared is just x squared, and then we'll have to square this one. Now remember, when you're squaring a binomial like this one and this one, we have to write it out twice and FOIL it. Okay, when in doubt, write it out. All right, so here we have x minus 7 times x minus 7. Okay, and you're going to see a lot of teachers they're not even going to show you this step. They're going to go straight from this, straight to the trinomial. Okay, but I'm going to show you the FOIL step here. And then this x plus 2 squared is going to be x plus 2 times x plus 2. Okay, let's go ahead and FOIL. All right, when I FOIL this, x minus 7 times x minus 7, first 2, x squared, outer 2, minus 7x, inner 2, minus 7x, and then the last 2. Negative 7 times negative 7 is a positive 49. This x squared right here just drops down. So plus x squared equals, let's go ahead and FOIL this one. X times x, x squared. X times 2, 2x. 2 times x, 2x. And then 2 times 2, 4. All right, FOILing is distributing. So every time after we distribute, we need to combine like terms. Let's go ahead and do that. You see any like terms on the left-hand side? Yep, I do. I have an x squared and an x squared. Oh, you know what? That's 1x squared plus 1x squared. What does that give me? 2x squared. I have minus 7x minus 7x. All right, you owe 7 more, minus 14x. And then the plus 49 is just by itself. I'm going to bring it down. When you combine like terms, you do it to the same side. Any like terms I have on the left side or any like terms I have on the right side, okay? I'm not ready to put the x's on the left together with the x's on the right. Not ready for that yet. All right, let's look at the right side. Can I combine like terms? Sure can. I have 2x plus 2x. That's it. So this x squared will drop down. 2x plus 2x is 4x. And then just drop down this plus 4 right here. All right, I have distributed, I have combined like terms. Now, let's get all of our, if it was linear, we'd get our variables to the same side, but this is not linear. This is a quadratic equation. So to solve a quadratic equation, we need to set it equal to 0, which means I don't want any of this stuff over here. I want to get rid of all three of these, okay? I want to get rid of this, I want to get rid of this, and I want to get rid of this. I want to turn it into a 0. So how do I get rid of this is a 1x squared, right? How do I get rid of an x squared? Minus x squared. How do I get rid of a plus 4x? Minus 4x. How do I get rid of a plus 4? Minus 4. Now if I do that to the right side of the equal sign, I need to do the same thing to the left side of the equal sign. Minus x squared. I know it's going to combine with my like terms right above. Minus 4x. And minus 4. All right, let's put it together. I have 2x squared minus 1x squared. Well, that gives me an x squared. I have negative 14x minus 4x. And it's going to give me negative 18x. And I have plus 49 minus 4 is plus 45. All right, what does it equal? What's x squared minus x squared? 0. What's 4x minus 4x? 0. What's 4 minus 4? 0. So it equals 0. Yep, you know it's coming. Smiley face. All right, and now, this is something that we did not too long ago. Okay, this is solving a quadratic equation. It already equals 0. That's very nice of them. So I need to factor completely, and I need to solve. Let's go ahead and let's put it in our two binomials. So this trinomial is an easy 1. It starts with the number 1. So my first two terms are going to be x and x. My last two terms need to multiply to give me 45. And then they're going to need to add up to give me 18. So let's come over on the side. Let's do that. I have 45. All the possible factors of 45. 1 and 45. Does 2 go into 45? No. Use your calculator. You'll get a decimal. 2 doesn't work. What about 3? Yeah, 3 works. 3 and 15. 4. Nope. 5. Yep. 5 and 9. 6 doesn't work. 7 doesn't work. 8 doesn't work. And back to 9. Now, these are my possibilities. Is it 1 and 45, 3 and 15, or 5 and 9? I'm trying to get 18. Here it is, 3 and 15. So, I'm going to have a 3 and a 15. Let's look at the signs. This plus tells me that they are the same signs. If it's a plus, they're the same. If it's a minus, they're different. And since they're the same, I'll look back here to find out that they are both negative. Okay. I have factored completely for my quadratic equation. Now it's time to set all my factors equal to 0 and solve. X minus 3 equals 0. X minus 15 equals 0. Let's solve the left-hand side. Grumpy old X wants to be by himself. How do I get rid of a minus 3? Plus 3 to both sides. And I will find out that X equals 0 plus 3 is 3. One of my possible answers. What about this one? X minus 15 equals 0. Grumpy X wants to be by himself. Add 15 to both sides. That way, you won't have any more 15 on the left. All right, on the left-hand side, my X is all by itself. And on my right-hand side, 0 plus 15 is 15. So I have two possible answers. Okay, now let's go and see which one of these are going to make sense. All right, go back to the original problem. We're looking for the length of the longer leg of the triangle. Okay, which one is that? Well, that's this one right here. That's the longer leg. Now, it could be 3, it could be 15, but let's think about this. If I'm looking at A, if I want to find the length of the shorter leg, I'm saying that x is 3. Well, this would be 3 minus 7. What's 3 minus 7? Negative 4? Is it possible to have a negative length? No, it is not. So this can't be the answer. I have to throw this answer out because it doesn't make sense. So that leaves me with 15. Let's try 15. I hope this one works. All right, back up to the triangle. Let's say I plug in a 15. That would make this 15 minus 7, right? X is 15. What's 15 minus 7? 8. Okay, I'll believe that. X here would be 15. Sure, I'll believe that. It's longer than this one. And then my hypotenuse would be 15 plus 2, which is 17. And I'll believe that too. All right, if you really want to check it, you can square 8. You can square 15. Add those two together, and it should give you 17 squared. Okay, so that's a calculator exercise for you to try. Now, to answer this specific question, what is the length of the longer leg? 15. Okay, it's not always what you get down here. You have to apply it to the problem.